Okay, marvelous Algebra 1 students, we are back in topic 7. This is lesson 7.2, titled Slopes of Parabolas. Lesson 7.1 is, of course, required viewing before this lesson because that's where we first learn about the idea of a quadratic equation. And can you spot any quadratic equations on this page? Hopefully you're spying that quadra, that square that's hanging out with each of these quadratic equations. We see those in all the b versions of the problems, 1b, 2b, 3b. However, 1a, 2a, 3a and 1b, 2b, 3b actually look very, very similar, don't they? If you examine 1a and 1b, they actually have the same numbers in there, x minus 1s, and then there's a minus 2 at the end. Looks like the only difference is the x minus 1 on the right is grouped with a square, and on the left is grouped with, do you guys remember what these are? These are absolute value bars. They give the distance of a number to 0, or sometimes we just say they turn a number positive. Do you remember the shape of the graph they make? Well, if you don't, it's also in the instructions up above. It says graph each absolute value equation in the shape of a V. And so each of these with the absolute value bars are going to make a V. And then graph the corresponding quadratic equation in the shape of a U to the right. So what that means, I think, then, is you should be able to graph everything in blue. No problem. We did that in topic 5. And then you're going to graph the similar quadratic equation. Don't forget the domain and range for each, and then we will come back together once you're done. Ready, set, go. All right, you're back. Let's get to it. Let's start with the absolute values, all those a's. There's a couple things we need to focus on here. First, our domain is going to be all real numbers every time for all of these, so I'm just going to quickly sketch those in. It's the same for the parabolas, the graph of the quadratics, and we'll put those in later on. The range, we'll probably wait until we get this graphed. So we know that this equation has a vertex, and our vertex is, of course, the opposite of h comma k, 1, negative 2. But then to make this perfect V-shaped graph, we need one other piece. And although in linear equations we called it m, for our HK form for absolute value, we actually called it a. It's the number hiding out front. It is essentially still m. So we're going to write that as a slope, up 1 over 1 in each direction. I'll continue out to the right, continue up to the left, and once we have a clear idea of what's going on, we can connect those and end up with our first graph. All right, now on to I guess we should do the range, huh? You'll notice that the lowest this graph gets is negative 2, and so the y values on this graph are above negative 2, but also equal to it. I'm going to stick with this notation for the range. It's more common for Algebra 1. If you wanted, you could write this from negative 2 to infinity. Same idea. Maybe I'll include that one just in case you have a fondness for our set notation there. Interval notation, sorry. Okay, 2a. Similar idea, we again have a vertex, don't we? Our vertex, opposite of h comma k, down here. And then I don't think we actually go up 1 over 1 this time, because we should notice that our a value is slightly different, or m if you want. It's 2 or 2 over 1, so we actually go up 2 over 1. Now, what that 2 is doing in front of the absolute value, it is, of course, changing the slope. But what it's really doing is it's doubling the output every time. If the 2 wasn't there, this answer would be half as large. So if we put the 2 there, it makes the outputs, it makes the y values twice as large. Or graphically, we can say the graph goes up twice as fast. And so although it's a little bit hard to see here, it shouldn't be too terrible, how would you visually describe the steepness or how fast the first graph goes up from the second graph? Well, there's a few ways to say it. You could say the first graph is wider, but if you wanted to discuss vertically, you could say that the second graph is vertically stretched. It's like pulled up towards the top, or it's skinnier. It goes up twice as fast, and that's because of the 2. So we need to remember, or know now, that the a value out front is going to stretch or compress. It's going to shrink or widen. our graph. And so the larger the number here, the faster our graph is going to go up, right? If this number was like 10, this graph would be really skinny because it's going up really, really fast. If it was smaller than 2, it would be less skinny. It'd be less vertically stretched, or it might even be compressed. Okay, our range here, it still gets down to -2, so we're not changing too much. We might remember from our last class that this range number is actually matching our vertex every time, isn't it? And because it's the same, then we can also still say -2 to infinity. All right, last one. We still have a vertex. Okay, +2, +1, right here. And now we have a slightly different a value. You might remember I always like to move the negative to the top of the fraction. You can either put it on the top or the bottom, not both. And then we can go down 1 to the right 2, or down 1 to the left 2. Something like this. So two things are different with this V-shaped graph than the other two. First, and most obviously, this graph goes down instead of up, and that's due to the negative. And second, if you compared the wideness, even if it was going up here, right, something like this graph is wider than the other two. But the reason it's wider is because of the 1/2. It goes up half as quickly. And if something doesn't go up as fast, it stays wider. And that's true even if the graph is opening down. This changes our range slightly. The highest the graph now ever gets is 1, and so the y's can be equal to 1, but they are also less than 1. The way we write this in interval notation is we actually always do the smallest number first. The smallest number is the number down here. The largest is at the top. So the lowest it's going to go is down to -infinity, and the highest is all the way up to 1. It gets to 1. It can never get to -infinity. My guess is if you switch the order, your teacher will probably still be pretty forgiving. This is just the more traditional way to write it. All right, so there's our nice review of topic 5. However, 1b, 2b, and 3b have a slight issue. Now, they are all in HK form, aren't they? Right? And in fact, the HK, the vertex for each of these, will be the same as the vertex for the absolute value. So let's put those in first. Vertex, vertex, and vertex. However, the actual graph is going to be less accurate than 1a. Do you see why? Well, maybe let's say you tried to graph using this hidden a value, and the a value is again 1. But if you went up 1 over 1 in each direction, why do we know this is wrong? Well, hopefully you've realized that that's because this graph is making a V, but we know our quadratic functions make a parabola, which is in the shape of a U. And I'm pretty confident that going up 1 over 1 in each direction won't make a U. So the way we concluded last class is we said, well, if it's going to make a U, we're just going to be somewhat sloppy about it, and we're just going to kind of sketch in a U-shaped graph. And for now, that is okay. However, once we've settled on the approximate width of our U-shaped graph, we can be a little bit more accurate for 2b, because there's a 2 in front. And so our parabola is going to go up twice as quickly. Instead of being kind of this width over here, I'm going to make my parabola a little bit skinnier. I don't like that left side. It didn't look like it was still going out. That one looks a little skinnier than the last. In a similar vein, for 3b, there is a negative, and yes, you are right, our parabola is going to go down, and the 1/2 means it's wider than the others. I'm not quite sure how wide, so I'm just going to kind of over-exaggerate here and make my parabola a little bit wider. The domain and range, though, are actually exactly the same as the absolute value. There's no difference in how we find them. So I'm going to put in the domain. I'm going to skip the range because it's already written over there. I'm not going to write it twice. Okay, now we come to the main theme of today. Although it is good that you can get the general shape of a parabola, today we are going to try to graph more accurate parabolas quickly. And so, to do this quickly, we are going to need some extra points to improve our accuracy. So go ahead and flip that page and we'll see what we need to do. First, a look at an updated formula for vertex form. There is a letter that's added in here that we did not discuss last class. We've discussed it quite a bit so far today. What letter is that? Oh, right. We've added in the A. The A still controls the steepness of our quadratic functions, of our parabola, right? So you can still think of A as kind of the slope or the rate of change. However, a lot of people take issue with you saying A is the slope because a parabola, much like an exponential, doesn't have a common slope. The only style graph we study with a constant slope is a line. It has the same steepness. So you can say A is the same. It measures the steepness. With parabolas, A changes the steepness. So it's the rate of change. It's how fast it is changing. All right? But you might say, well, cool, it changes the steepness and everywhere is a different steepness, so how does that help us graph? Well, there is a nice bonus. The A value will actually help us find 2 extra points. No more than that, just 2. Also, side note, there is a way to use the A value to find more than 2 points, but for now, we're really just going to use it to find 2. If you want to know more about why this technique works, definitely make sure you finish up to either pre-calculus or especially calculus. Once you start to learn the idea of a derivative, it will explain why this works. But for now, let's use our shortcut for the A value. The A value for a parabola can help us find 2, no more, points near the vertex. However, in order to do that, A must always be written as a fraction with a denominator of 1. Fraction with a denominator of 1. So let's quickly practice that. First one shouldn't be too bad. This is an A value of 2, so to write it as a fraction over 1, 2 over 1. That tells us there is a rise of 2 and a run of 1. Easy enough. Second one, a little bit trickier. There's a negative 2 this time over 1. It tells us there's a rise or kind of a fall of 2 and then a run of 1. Third one's the trickiest so far, but you've done this enough, I bet you won't even hesitate. There's an invisible 1 here. So negative 1 over 1, which means rise down 1 and run over 1. But the last one is what throws so many students for a loop, because they want to go through and say, ooh, 1/2, there's my A value. But you've broken the cardinal rule of A values of parabolas. A values must be written as a fraction over 1. So what do? Well, I get 2 options from students. Either they say, well, we'll just make it work. I'm going to do 1/2 over 1. Is that allowed? Sure. It means that you want to rise up half a unit and then run over 1. However, some other students say, ugh, fraction and a fraction, that's pretty gross. I bet I can do it a different way. Do you see how? Well, instead of 1/2, isn't that the same as 0.5 over 1? And it is. So it either means up 1/2 or up 0.5. That's the same thing. And then over 1. And that is extremely important. And we'll talk about how you could possibly do it wrong down below. Because you might notice with these 4 equations down below, each equation has been analyzed up above. Our second one right here, and so on and so forth. So what we're going to do, and if you're in a group, this is a great time for some group work, is you are going to do the first problem with me and everyone on their own paper. We are going to plot 3 points on our parabola. Let's start with the vertex, and I'll even include this so you can take a look at this later on when you're doing your independent practice. Negative 2, h though, we're going to treat that as a positive 2, negative 3. 2, negative 3. Then we're going to use the A value. My A value here, let's do that in a different color so it pops. A is going to be 2 over 1. So we go up 2 to the right 1 and up 2 to the left 1, and no more. You cannot use the A value anymore. If you continue to use the A value, now you have made a V-shaped graph, and that's not what we're doing. 3 points is still enough to create a U or a parabola. So once you've done that, bring out your inner artistic skills and turn this into a parabola. We can see that this parabola is a little bit skinnier. It's vertically stretched. It's going up twice as fast. And that's that. Now, go ahead and take a couple minutes and work with your group. You're actually going to give your paper to the person who is clockwise or to your left from you. You are going to receive a paper from the person from your right. Once you have done that, go ahead and do the next problem. Once everyone in your group finishes, rotate and do it again, rotate and do it again. Once you've finished all problems on this page, please pass the paper back to the original person. Then you can unpause and see how you did. Ready, set, go. All right, hopefully you guys found some success. These really aren't too bad, except maybe that last problem. So we have -2, 5, left 2, and up 5. And then, of course, our A value is down 2 to the right 1. We also, though, have to go down 2 to the left 1. And then we have our parabola. I'm doing my best to make sure it looks like a parabola and not a V. Very easy to turn this into a V. Next, we have our invisible 1 here, but we still have that vertex. Not bad. -2, -1. Right, those are right here. And then our vertex, that -1, means we should go down 1 over 1. There's one, there's the other. Don't forget that -a value will cause our parabola to open down. Last but not least, a little tricky in two different ways. First, finding the vertex can be tough because we can certainly see the h, +2, but the k has nothing going on at the end. What can you add that doesn't change the equation? Oh yeah, 0. 2, 0. And then the second trick is, of course, that a value, which we did up above. I'm going to write this as 1/2 always over 1 for parabolas. I'm going to zoom in here so you can see both the right and the wrong way to do it. Some students will think this means to go up 1 over 2. And I'm going to do this in purple. Erase this so that you can see our parabola actually isn't going to go through those points. Up 1 over 2, up 1 over 2. And I'll even make them x's so you can really see that those are the wrong points. The right way to do it is to go up 1/2 to the right 1, up 1/2 to the right 1, up 1/2 to the left 1. And so we can see that they won't go through here. That would make a V. Instead, our parabola is going to look something like this. A little bit wider than normal, but it's certainly not going to pass through an up 1 over 2. But I think I promised you guys 5 points instead of 3. And if I didn't, I apologize. By the end of today, we are going to be making parabolas that pass through 5 accurate points quickly instead of 3. And notice we've really had to do no math here, and we've already improved the accuracy. So let's get even better. The second technique we're going to use is involving the y-intercept. We focused a lot on the y-intercept last semester and even last unit. Maybe we focused enough on it that you remember how to find the y-intercept. You need to replace something with 0. Do you remember what? Well, yes, it is the x with 0. That will allow us to find the actual value of the y-intercept. Now, you should have a calculator out for this because we want to practice our calculator skills daily. We're going to run across some problems eventually where you will need a calculator or you really, really won't want to do it by hand. So, let's go through and get this done. For each of these, and I'll show you first by hand, and then I will also hopefully help you remember how to do this with the calculator, how to do the work for the y-intercept. So for the y-intercept, the first thing we need to do, here's this equation. Does this equation look familiar? Oh, well, it should, because this equation is here, and it's back here. It's the same equation again. We're just going to take that graph and make it more accurate. So the first thing we do is we replace the x with 0. And that's why in our final answer, the point has an x value of 0. Then, as we mentioned last class, we follow PEMDAS. And this can go pretty quickly when you get good at it. So for PEMDAS, we do what's inside the parentheses first. And so that gives us 0 minus 2. That's negative 2. So P is done. Then we're into the exponent part. For the exponent, we need to do negative 2 squared. And negative 2 times itself, negative 2 times another negative is a positive 4. We've taken care of the exponent. Right, that was that guy up here. Now we're on to any multiplication we might see, and there is multiplication here. 2 times 4 is 8. There is no division, no addition, but there is subtraction. And our subtraction tells us to do 8 minus 3, which is 5. That means our final y-intercept is the point 0, 5. Now, if you have your calculator, all you're doing on your calculator is you are just taking between the first two equal signs and substituting that in to your calculator. As a word of warning, though, on your tests and on your knowledge checks, your quizzes, you are required to show that blue piece that I highlighted on the page. You need to show the setup, and then if you want to do the math on your calculator and skip to the answer, that's fine. Must show a setup and an answer. All right, let's try the other couple. For this one, I changed the f of x to a y. There's no real reason not to. It just takes up a little less room, and then we need to replace the x with 0. You can try to match me with your calculator, but I bet I'll probably be faster. 0 plus 2, 2 squared is 4. Negative 8 plus 5 is negative 3. Next one, it might help you to put in that invisible 1 there. So we have negative 1 times 0 plus 2 squared minus 1. 2 squared is 4. Negative 4 minus 1 is negative 5. And last but not least, y equals 1/2 or 0.5. 0 minus 2 squared, we always show the setup. Negative 2 squared is 4. And half of 4, I think, is 2. Great. We've done the hard stuff. Now, here's what threw my students off. We did all the work for the y-intercept here. And now it seems like we're jumping down to these random graphs. So what we're going to do is we're going to try to graph each of these equations with 5 accurate points. But you might say, well, wait, like I can do the vertex, right? Let's go ahead and tackle the vertex right now in this. It looks like the vertex is going to be positive 2, negative 3. Okay, and I can do the a value. That's not bad, right? A is 2 over 1, means go up 2 over 1 to each direction. Cool. But then how do I do 5 points? Oh, do I have to do the y-intercept thing we did up here? Well, yes, you do, except you might want to remember that these two equations are the same. So we've already done the y-intercept. We know the y-intercept for this, just from up above, is the point 0, 5. And 0, 5 is up here. So now we can sketch in this parabola because it has our 5. Wait, I only count 4 points. I promised you 5 points, but I only see 4. How do you find the 5th? I bet you see it. Right? You might notice that these points have symmetry. They are an equal distance from the center of our graph. In fact, we call the center of our graph an axis of symmetry. Many times you'll see students and teachers draw in this dashed line here. That's so we can visualize the center. It's called our axis of symmetry. And so you can notice that this red point is 1 away from the axis of symmetry on one side and the same on the other. This yellow point is 2 away on one side, so we could probably put its mirror image or corresponding point 2 away on the other side. At this point, doesn't that give us our nice 5 points that we're looking for? And now we have quite an accurate parabola. In fact, we used 5 points. That's way more than what we use for a line. A line only takes 2 points. So go ahead, please. Try the last 3 problems. See how you do. And you can unpause to check your answers. Ready, set, go. All right, you're back. Let's take a look. I'm going to quickly go through and put all the points that we found before. I'll do them in red. So we had negative 2, 5, down 2 over 1, down 2 over 1. Here, negative 2, negative 1, down 1 over 1. And last, 2 comma 0, up a half over 1, up a half over 1. Now let's improve the accuracy with these using the y-intercept. This one on the upper right has a y-intercept of 0 comma negative 3. That might be further down than you might be expecting. So 0, negative 3 is down here. Notice that's not down 2 over 1 with the slope. The mirror image through that axis of symmetry, 1, 2, 1, 2, is negative 4, negative 3. Now we get a fairly accurate parabola. Our next one, we found a y-intercept for this guy as well. It was 0, negative 5. Had to look up earlier to actually remember what it was. There we go. And our axis of symmetry tells us we can have another point, negative 4, negative 5. There's one, and there's our second. Last but not least, we again had a y-intercept here. I think this one's at 2. It is y-intercept of 0, 2, like so. And that axis of symmetry shows us that we can also have the point 4, comma 2. This parabola is wider than the others, as it should be with the 1/2. It goes up half as quickly. Right? This axis of symmetry is that dashed line I did every time. You don't always have to include it, but sometimes problems will. So, to conclude today, we're already done, it's crazy, we have a single practice problem. There are a bunch of parts, but it's really everything we did so far. In fact, I think it's important enough that we based your knowledge check next class off of this. So, try to work through this. You should end with a parabola containing 5 points. Once you've done it, go ahead, unpause, check your work, and that's it for the day. Good luck. All right, hopefully you have it. Let's begin. Vertex, positive 2, positive 3. Easy enough. A value is a fraction. A equals negative 2 over 1. Down 2 over 1, down 2 over 1. Can I keep going down 2 over 1? Nah, that would make a V. We're not doing V-shaped graphs. There's a square. That's the giveaway. It's a parabola. All right. Moving on through. We have our first 3 points. That's what C asked us to do. Now we need the y-intercept. I've mentioned this before, but you always need to show a setup and an answer to your problem. To find the y-intercept here, we're going to take our equation. Y equals negative 2 times x minus 2 squared plus 3. And we are going to replace the x with 0. That is where this 0 comes from. Then you can either put all of this into your calculator and come up with your answer, or if you would like, you can put more work here. Mental math isn't too bad though. Negative 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 plus 2 or plus 3 is negative 5. So we have our y-intercept of 0, negative 5. Let's go ahead and graph our axis of symmetry. Our axis of symmetry always goes through the vertex. Because it goes through the vertex vertically, it also goes through the x-axis. And in fact, last semester we learned how to write the equation of lines that go through the x-axis. We write them in just the form x equals the x-intercept. So my axis of symmetry has the equation x equals 2. Well, now we have the y-intercept, moving on to part F. That is 2 away from the axis of symmetry. So if I go 2 to the other side, we should have a second point. Finish graphing by connecting the points. Don't forget the arrows at the end. All right, thank you, Mr. Directions. There's one. There's my arrow. And here comes the second one. And there's my arrow. Good. Last but not least, domain and range. You guys will do this one no problem. All real numbers. Or you could do negative infinity to infinity. Or you could also do something like this. Our range, nothing too bad. The range measures the height of the graph. The highest the graph gets is 3, and then it goes below 3. So we could say the y's are less than or equal to 3, or the lowest it gets is negative infinity, the highest is positive 3, and it looks something like this. Well, at this point, we are done with the lesson. So what I'm really looking for to conclude this lesson is a list of steps explaining how to graph a quadratic equation in the form of this guy right here. And realistically, your steps should explain how to find 5 points on the parabola. They need to address the vertex, they need to address the a value, and they also need to discuss the y-intercept and symmetry. So take your time, go through, write out your steps so that when you have this quiz, this knowledge check next class, you know exactly what you're doing since you can use your notes on it, and you'll be just fine. Thank you as always for hanging out with me today. I'm excited to have you back for 7.3, which will be an awesome review of every graph we've done this entire year. No joke. So be ready for that, and hopefully you enjoyed today.